Okay, I will start recording. Hi guys, my name is Boris, and today we will talk about design patterns. Do we need them? Tatiana will tell us, and the presentation will take approximately 30 minutes. After presentation, we'll have time for your questions. So, yeah, it seems to me that's all from my part. Tatiana, are you ready?
Yes,
Okay, microphone for you.
thank you, Boris. Hi, guys. I'm Tatiana Zinkovich, a software engineer at EPAM, and today we are going to talk about design patterns. Do we need them in Ruby? So, what are the objectives of today's talk? First, you will find out the difference in terminology. What's the difference between design principles, design patterns, and algorithm? How to name them correctly. Then we will talk about what are design patterns themselves. Then we will proceed to overview of the most popular design patterns in Ruby. I want to draw your attention that it will be in Ruby popular patterns, and then I will provide you some useful links where you can deepen your knowledge, and in the end you can ask your questions. So let's begin. Let's first clarify the terminology. When somebody says you, could you implement here the following design principles or design patterns? What's the difference? When we talk about design principles, it's core abstract principles that we are supposed to follow while designing software. You know them all: solid, dry, keys, etc. They provide high-level guidelines to design better software applications and do not provide implementation guidelines. In comparison, design partners, that's solutions that we can choose to real-world problems that pop up again and again. You know them, of course. Just some examples: factory, builder, adapter. We will talk about them later today. Design patterns provide low-level solutions related to the implementation itself of commonly occurring object-oriented problems. If we compare algorithms and design patterns, what are the difference? While an algorithm is a well-defined set of instructions that always defines a clear set of actions that can achieve some goal, a design pattern is a high-level description of a solution. So you can see that design patterns go above algorithms, and design principles go even higher than design patterns. And there will be three steps. We can see it like this. So you can implement a design pattern in various ways, whereas you must follow the specific instructions in an algorithm. That's one more difference. After that introductions, you probably can name yourself the definition of design patterns. It's typical solutions of commonly occurring problems in software design. It's not a specific piece of code, but a general concept for solving a particular problem. Why to use them? First, it's a toolkit of tried and tested solutions. You don't need to reinvent a wheel. It was done before you by other software engineers. So just take it and use it. It also helps to define a common language. When you talk with your colleague, hey, let's implement a factory pattern here, you will both know what to talk about. As from the first point, while it's tested solutions, they will help you to accelerate the development process, and in the result, you will save your time. When you talk about design partners, you can hear quite often GOF. What is that? So basically, it's a short name of Gang of Four. There were four guys who published a book about design patterns, where they applied the concept of design patterns to programming. So there were 23, if I'm not wrong, design patterns that we use till now. Um, Let's see what we will talk today about. First, we will talk about creational design patterns. Here you can see a table. It's about Ruby and the popularity and complexity of implementation this pattern in Ruby. So we will talk today about abstract factory, about builder, and about a factory method. I've chosen them because you can see the popularity is 3 stars. So we will talk only about the winners today. What is creational patterns? They provide various object creation mechanism which increase flexibility and reuse of existing code. So when you see something is created, you might think about creational design patterns. And they are not all listed in this table. It's just the most popular. And then we will talk about structural design patterns. And here we will talk only about adapter, who has 3 stars. So what is structural patterns? Those patterns explain how to assemble objects and classes into larger structures while keeping those structures flexible and efficient. So you've created something and now you want to assemble. And then we will talk about behavioral design patterns. The winners here are command, observer, iterator, and strategy. What are behavioral patterns? That's the patterns that are concerned with algorithms and the assignment of responsibilities between objects. Let's go further and let's start with factory and abstract factory. So on the left, I made it to make it more easier to compare both factories and to see the difference as well. So factory on the left. Most commonly, factories produce objects, but they also can produce files, records in databases, for example, and etc. If you have a creation methods in a base class and subclasses that extend it, you might be looking at the factory method. The factory method is widely used in Ruby code. It's very useful when you need to provide a high level of flexibility for your code. In factory pattern, we create object without exposing the creation logic to the client and refer to newly created object using a common interface. You can see when to use it. For example, you can use factory when you don't know beforehand the exact types and dependencies of the objects your code should work with, or when you want to provide users of your library or framework with a way to extend its internal components. Also, you can use it when you want to save system resources by reusing existing objects instead of rebuilding them each time. There are also some other cases. To make this presentation shorter, I name only the most useful, the most often used cases. What is about abstract factory? Abstract factory let you produce families of related objects without specifying their concrete classes. You see, it's important, it's about families. So what are the families of objects? For example, let's take this set of classes: transport plus engine plus controls. There might be several variants of here. This abstract factory will produce, for example, car plus combustion engine plus steering wheel, or the same abstract factory can produce plane plus jet engine plus yoke. That means car can only work with combustion engine and steering wheel. They are not interchangeable, but this factory produce this set of 3. When you use abstract factory, for example, if your program doesn't operate with product families, then you don't need abstract factory. You can start with simple factory. Abstract factory patterns work around a super factory, which creates other factories. Some people call abstract factory as factory of factories. So the good advice here, when you need factory. Probably you will start with factory that will evolve later in abstract factory. It will be less complicated and more easy way of software development. You use abstract factory when your code needs to work with various families of related products, but you don't want it to depend on the concrete classes of those products. They might be unknown, for example, beforehand, or you simply want to allow for future extensibility. Also, you can use abstract factory when you have a class with a set of factory methods that blur its primary responsibility. It's important to mention here that both factory and abstract factory relies on inheritance. I will not provide code examples here. It's more a general talk today, but I will provide you later some resources when you can see concrete Ruby examples of all those patterns. So let's proceed to another creational mechanism, creational design pattern, and it's gonna be builder. The very simple idea behind the builder pattern is that you encapsulate object construction logic behind a class of its own. The builder class takes charge of assembling all the components of a complex object. You need to assemble something. Each builder has an interface that lets you specify the configuration of your new object step by step. In a sense, a builder is a sort of like a multi-part new record where objects are created in extended process instead of all in one slot. Builder, as I said, allows you to construct complex objects step by step. It doesn't allow other objects to access the product while it's being built, unlike other patterns, for example. It also doesn't require products to have a common interface that can be very suitable for some cases. And also it allows you to produce different types and representation of an object using the same construction code. For example, you can look at the picture on the right. When you build a house, you can apply a builder pattern, and you will build walls separately. You will build doors, windows. All of them can have different interfaces. You will step by step configure your building, and in another building you will not need, for example, doors, or I don't know, something. For example, garage you don't need, and you will not include it. The builder pattern will allow you to do so. So you use builder pattern when you want to create an object with lots of possible configuration options. Different representations of some product, for example, stone and wooden houses, as I said. Also, you use it to construct composite trees or other complex objects. What about nodes here? Many designs start by using factory method. It's less complicated and more customizable also, and then evolve toward abstract factory that we discussed on the previous slide, or it might also evolve to prototype or builder. More flexible, but more complicated. Builder focuses on constructed complex objects step by step, but abstract factory specializes in creating families of related objects. That's how easier to grasp the difference, one of the points. Also, abstract factory returns the product immediately, whereas builder lets you run some additional construction steps before fetching the product. It doesn't allow you to interfere in the middle of the process. Okay, I think we've done with builder, and let's go to the structural design pattern, and it's going to be probably the easiest one, an adapter. Adapter allows objects with incompatible interfaces to collaborate. For example, it can help you to convert data into various formats. You had XML, for example, and you need in the end to get JSON. You can use it when you want to use some existing class, but its interface isn't compatible with the rest of your code. The In this sense, the adapter pattern lets you create a middle layer class that serves as a translator between your code and the legacy class, or a third-party class, or any other class with a weird interface. Also, when you want to reuse, you can use adapter when you want to reuse several existing subclasses that lack some common functionality that you can't add to that superclass. But you can put this missing functionality into adapter class. Then you would wrap objects with missing features inside the adapter and gain the need features dynamically. And one more point when you probably want to use adapter, it's to make legacy code work with your modern classes. Some notes here. Breach, state, and strategy, we will talk about strategy later, and to some degree adapter, have very similar structures. Sometimes the difference may be very blurred, and you probably can't even clearly say which pattern is applied here. It's okay, it can be like this. Indeed, all of those patterns are based on composition. About factory, we talked, they are based on inheritance. So composition is when you delegate work to other objects. However, all these four patterns, they solve different problems. Adapter changes the interface of an existing object, while when you look at the decorator, for example, also a structural pattern, it enhances an object without changing its interface. One more difference, if you look at the decorator, I think you know this pattern, we don't talk about it here, but it's very widely used. It supports a recursive composition, which isn't possible when you use adapter. So let's go about two behavioral patterns, and we will talk here about strategy. Imagine that you have to get to the airport. That's probably the most famous example when you talk about strategy. You can catch a bus, order a cab, or get your bicycle. That's all your transportation strategies. You can pick one of these strategies depending on factors such as budget or time constraints. The basic idea of strategy pattern is to delegate tasks to encapsulated algorithms, which are interchangeable at runtime. The key idea of the strategy pattern is to define a family of objects, we call them strategies, which all do almost the same thing and support the same interface. Then the user of the strategy, the user of the context, can treat the strategies as interchangeable parts. What strategy does? It lets you define a family of algorithms, put each of them into a separate class, and make their objects interchangeable. In other words, it turns a set of behaviors into objects and makes them interchangeable inside original context object. It suggests that you take a class that does something specific in a lot of different ways and extract all of these algorithms into separate classes called strategies. You can also look at the picture on the right, how we can make the strategies of one context. When you probably want to use strategy pattern, when you want to use different variations of an algorithm within an object to be able to switch from one algorithm to another during runtime. Or the next case, when you have a lot of similar classes that only differ in the way they execute some behavior. Or to isolate the business logic of a class from the implementation details of algorithms that may not be as important in the context of that logic. And the last but not least case, when your class have a massive conditional statement, for example, case lack of budget, use public transport. Case, budget between this and that, use road strategy. And case, you have a lot of money, use private driver. So to reduce this conditional statement that switches between different variants of the same algorithm, you can choose a strategy partner. Some notes that differ strategy from other design patterns. Strategy lets you change the goods, while decorator lets you change the skin of an object. Command and strategy may look similar because you can use both to parameterize an object with same action. However, they have very different intents. Strategy usually describes different ways of doing the same thing, letting you swap those algorithms within a single context class. While command, we will talk about command right now. Command is also a behavioral design pattern that used to store the information necessary to call methods at a future time. The command is merely a set of actions wrapped in an object. It's very often used in event-driven architecture. When Ruby, we can use also procs to do the same thing without the need to create a separate object. It's a good idea that sometimes you don't need to implement some specific design patterns unless you have specific reasons for that. So here you can start with procs, and this is a good option when the action is simple and doesn't require save state information. Otherwise, if you need save state information, think about using a command class. That can be a better option. What does command pattern? It turns a request into a standalone object that contains all information about the request. This transformation lets you pass requests as the method arguments, delay or queue requests execution, and support undoable operations. Command in this sense become a convenient middle layer that reduces coupling between the graphic user interface and business logic layers. You can see it also this save command like a middle layer between user interface and business logic. When we are going to use command pattern, as I said, when you want to parameterize objects with operations. Also, for example, when you want to queue operations, schedule their execution, or execute them remotely. Or when you want to implement reversible operations, like do, undo something, so that to save the state what was before. The most typical differences between this behavioral pattern and other behavioral patterns. For example, chain of responsibility. We don't talk about it this pattern today. Mediator, command, and observer addresses various ways of connecting senders and receiving of requests. While they have some slight differences. For example, command establishes unidirectional connections between senders and receivers. Command strategy may look similar because you can use both to parameterize an object with some actions. However, they have different intents. You can use command to convert an operation into object. The operation's parameters become fields of that object, and the conversion lets you defer execution of the operation, queue it, store the history of commands, send commands to remote servers, and etc. So let's proceed to observer. The last but one pattern that we will talk about today. What observer does? It defines a subscription mechanism to notify multiple objects about any events that happen to the object they are observing. You can very often to see it implemented in front end, especially in some other languages as well. The observer pattern is for event-driven programming as well as common pattern. An object called the subject maintains a list of dependents called observers and notifies them automatically of any state changes, usually by calling one of their methods. The Ruby standard library includes an observable module that implements this pattern. It's also possible to use code blocks as observers. When you're going to use it? First of all, when changes to the state of one object may require change in other objects, and the actual set of objects is unknown beforehand or changes dynamically. You can use it when some objects in your app must observe others, but only for a limited time or in specific cases. As other behavioral patterns, like chain of responsibility, common mediator, and observer, they address various ways of connecting senders and receivers of requests. Nevertheless, observer lets receivers dynamically subscribe to and unsubscribe from receiving requests. The difference, if you compare mediator and observer, for example, is often elusive. And it's not only the case when the difference, as I said, between several design patterns is elusive. But in most cases, you can implement either of those patterns. But sometimes you can apply both simultaneously. One of the differences, small differences, is the goal of observer is to establish the dynamic one-way connection between objects, where some objects act as subordinates to others. Let's proceed to iterator. It's the last design pattern that we will talk about today, and it's behavioral design pattern. This pattern is very common in Ruby code. Many frameworks and libraries use it to provide a standard way for traversing their collections. This pattern provides sequential access to elements within a container without exposing how the container actually represents the elements. You can see on the picture with these patterns, you can say in which way you would like to iterate over some set of over some collection. So iterator provides sequential access to elements within a container without exposing how actually the things are working inside. The iterator can be thought as a movable pointer that allows access to elements encapsulated within a container. It lets you traverse elements of a collection without exposing its underlying representation. For example, what is inside list, stack, tree, or something else. The main idea is to extract the traversal behavior of a collection into a separate object called an iterator. You probably, when you probably want to use it, when your collection has a complex data structure under the hood, and you want to hide its complexity from clients for some reasons, or when you want to reduce duplication of the traversal code, or you want your code to be able to traverse different data structures, or you don't know what the data structures are going to be. Iterator is easy to recognize by navigation methods such as next, previous, and others. It might be a good idea to meet together factory pattern and iterator because it will let your collection subclasses return different types of iterators that are compatible with the collections. And here I will show you useful resources. To my mind, one of the best one is Refactoring Guru. You can also read orally several books with different depths of diving into the topic. You probably want to look at LinkedIn, some video tutorials, but I will highly recommend you to pay attention to the last two links. It's repositories in GitHub with Ruby code on each design pattern, and it's written in very simple language and with simple code examples, which I consider is absolutely great. So that's all what I wanted to talk about today. Maybe you have some questions.
Yeah, thank you, Tatiana, for amazing presentation. Yeah, guys, it's a good time to ask question. Feel free to write or unmute yourself and ask Tatiana something.
So let me start. Thank you, Tatiana, for great presentation. It's a really important topic, and I have maybe a general question. In your opinion, what is the best way to recognize this pattern to start using it?
First, you can think what are you gonna implement? Is it gonna be a creation of something, or you have already something created and you need to do something with it? For example, you want to assemble objects, then you would probably look into structural design patterns, or you have already it and you think about how to assign the responsibilities between objects. So it depends actually what your goal, and then look which one is describes better the solution for your problem.
Okay, got it. Thank you.
I think I can add a few moments regarding this question. So I think that if we use Robocop and Robocop force us to create smaller classes, then we will start thinking about how to refactor the code. And when we have different choices, different design patterns in practice, we can apply this. Because if we just write the code with 1,000 of lines, there is no need to implement patterns. Yeah, you just write as usual, as in the easiest way. But if you want to divide it, you can apply these patterns and see how they could improve your code, your readability and maintainability of the code.
Okay, thank you for this addition, Evgeny.
Okay, guys, other questions? Okay, Tatiana, thank you again. We will share presentation to you and recording. Okay, I can stop recording right now.